G'day, Year 9. Welcome to McGrathmatics for your first online lesson of 2021. Thank you so much for joining me. We're going to rip into a new topic today called factorizing, which is something that we've done a bit of when we studied algebra earlier in the year. But we only really looked at one or two types of factorizing. In this topic, we're going to explore multiple different ways of factorizing different algebraic expressions. So I think this is a really awesome topic. It was one of my favorites when I was a junior student many years ago. So hopefully you find enjoyable as well. Let's dive in and see how we go. We're going to start with today's heading on grouping pairs factorization. Okay, I'll explain what that means shortly. Before we get into some of the grouping pairs factorization, we're just going to do a quick recap of some factorizing that we've done earlier in the year. So I want you to pause the video and see if you can remember how to factorize, which is kind of like unexpanding these expressions. So see how you go. If you're not really sure, of course, you can just wait for me to talk through it. Okay, so for this first one, we are trying to look for the highest common factor of these two terms. So the largest thing that multiplies into 8x and into 56. The answer to that is just 8. So we're going to reverse expand. We're going to pull an 8 out of both of these expressions, which is going to look like this. If we pull an 8 out of 8x, we just get x left over. We're going to have a minus inside the brackets, and 8 factored out of 56 gets us an answer of 7. Okay, good thing about factorizing is you can always check your answer. If you expanded the right-hand side, you would get the left-hand side as your answer, so we know we've done it correctly. For question B, the highest common factor of 9m squared and 3m, well, looking at the numbers, the highest common factor is 3. Looking at the algebra, the highest common factor is an m. So we're going to pull 3m out of both terms. If we pull 3m out of 9m squared, we're going to be left with 3m. If we pull 3m out of 3m, we're just going to be left with 1. Okay, if we expanded this, we'd get 3m times 1, and we get 3m on the left-hand side. Okay, C is a bit of a tougher one. First of all, looking at the numbers, 48 and 64. The highest common factor of those two is actually 16, I believe, because 48 is 3 16s and 64 is 4 16s. So sometimes you can factorize a question, but you might not get full marks because you haven't fully factorized, because there's still a factor remaining inside your bracket that you could have pulled out. Okay, so if you pulled out, say, 4 or 2 from these two numbers, you're going to get some marks, but you won't be getting full marks. So 16 is the highest common factor of the numbers. Of the algebra, in both terms we have an x squared, and in both terms we have a y. So we're going to pull out 16x squared y out the front. Out of the first term, it leaves us with just a 3 because we've pulled all the algebra out. Out of the second term, it leaves us with a 4 because 16 times 4 is 64. Out of the algebra, we're left with an x and a y. So there is our factorized expression. Now, D and E are a bit trickier. Some people find these ones harder to see at first, which is all good. So our two terms are this front part and this second part right here. Now, if we're looking at these two and we're saying to ourselves, what's something that's in common that I can pull out of each of these? Well, the thing in common is an x plus 2. So we're going to pull that bracket out of each individual term, which is going to look like this. So we pull x plus 2 out the front. It leaves us with x in the first part, and in the second part it leaves us with plus 5. So inside our bracket is x plus 5, which was that piece there and that piece right there, with the x plus 2 pulled out the front, and we have our factorized expression because we have two things multiplying. That's what factors are, they multiply. Okay, and for E, it's the same idea. We have two expressions or two pieces where the common part is the 2n plus 1. So we're going to pull the 2n plus 1 out the front. It's going to leave us with 3, take away m to be in our second bracket. All right, so D and E is leaning into what we're doing today, which is called grouping pairs factorization. We've got to be able to factor brackets out the front of another bracket, which is what's happening here. So it's, like I said, it does take a bit of getting used to it first, so go slow if you need to. Okay, here's our first question. We are going to factorize this expression. We've got 2x plus 8 plus bx plus 4b. Now, when you are factorizing something, what we're trained to do is we are scanning through to look for common factors. Now, if you've already done that, you may notice that there's nothing in common to all four of these. There's a 2 in these three, there's a b in these two, there's an x in these two, but there's nothing apart from 1 that's in common to all 4 terms. So the way we're going to get around this is these questions are oftenly designed so that you can factorize the front half, factorize the second half, and then you can factorize them together. And this is what grouping in pairs factorization is all about. So let's see how we go. If we factorize the first half, 2x plus 8, how could you factorize that? Well, it's got a common factor of 2, so we could pull it out and have 2 outside of x plus 4. For the second half, we could do the same thing. We could say, what's in common to bx and 4b? Well, we could pull a 4 out the front, and we've got x plus 4 left over inside the bracket. So front half factorized, back half factorized. Now looking at this, we can see, well, hang on. Now we have an x plus 4 that's common in both pieces. Like we did in the last 2 examples on the previous slide, we can factor the x plus 4 out of both of these, have it out the front, leaves us with 2 plus b remaining on the inside. And there we go, we've factorized it. So we kind of factorize it in individual halves so that we can then factorize it together using this method that we just covered. So this is called grouping in pairs factorization. Let's have a go at another one. Okay, next one we've got 2x squared plus 10xy, take away 3xy, take away 15y squared. Once again, there is nothing that is in common to all 4 terms, so we're going to be clever and we're going to factorize the front half, factorize the back half, and then if we've done it correctly, we should be able to factorize the whole thing together after that. So think about what's in common to these 2 terms, and then think about what's in common to these 2 terms. This one's a little bit tricky because we've got some negatives floating around, but we can still handle it. In the front 2, we've got a common factor of 2, and we've also got a common factor of x, so we're going to pull 2x out of these 2. All right, so we get 2x out the front of x plus 5y. There's the front half factorized. Now in the second part, we can see a common factor of 3y in both of these terms. But what we're also going to do is we're going to pull out the common factor of the minus. So we've got a minus 3 here and a minus 15 here. So if we pull the negative 3y out of these 2 terms, we get this. We get x at the front, we get 5y at the back, and now we have a plus here. Why is that a plus? Well, think about it. If you expanded this front term would be negative 3xy. And if we expanded this back half, negative 3y times positive 5y is equal to negative 15y squared. If that thing there was a negative, expanding this, a negative and a negative would give us positive, so it would not work. So if you're factoring a negative out of a negative, it's going to leave you with a positive. Yeah, pretty gnarly. But the reason we need to do that is because we need this bracket, this parentheses term, to be the same at both the front and the back so that we can factor that out of both of them and get our final answer. So we're going to factor x plus 5y out of the front and the back term, leaves us with 2x, take away 3y. So that should be a y right there. I've written x because I'm really, really dumb. I want you to write a y in your books, please, boys and girls. All right, so if that right there was a y, that'd be a fully correct answer, but you know, I got pretty close. I'll get half marks for working, so it's pretty good. Let's do another one. Okay, up next we've got x cubed plus 5x squared, take away x, take away 5. This one's got another little trick to it. You're welcome to pause and have a go by yourself if you want. Otherwise, I'm just going to dive right into it. So the front half, x cubed and 5x squared. What do we have in common in both of those? Both of them have a x squared. So let's pull an x squared out of these 2. Leaves us with x and leaves us with plus 5. Now looking at the second half, we know we want to factor something out so that we get x plus 5 inside a bracket. The trouble is, there's nothing in common to x and 5. The only thing that's in common here is the minus. Well, let's just pull the minus out of both of them. So minus out of x gets you just x, and the minus out of minus 5 gets you 5. We put it in a bracket, and I'm going to cough now, pardon me. Gross. Now we have x plus 5 in a bracket in both terms. Now we can take it and factorize it out the front, which is what we're trying to do. Okay, so we've got a common term of x plus 5. Factoring out the front, it's going to leave us with x squared in this term. What's it going to leave us with if we factor it out of this? It kind of feels like there's going to be nothing left until you realize that what's really in front of this bracket is an invisible 1. So imagine this is minus 1 out the front of x plus 5. if you factorized x plus 5 out, you would be left with minus 1. So we have x plus 5 out the front, leaves us with x squared minus 1 inside the bracket. All right. And that's really as tricky as these ones get. If that makes sense to you, you're going to be really fine with this lesson, I would think. All right, now you've got a rough idea. I want you to have a go at these 5 questions. The last one is a bit of a challenge question for you, Travis, or anyone else. So pause the video, see if you can follow the pattern that we just established to factorize these 5 expressions. And in a short moment, I will show the answers for you. And that feels like a short moment, so let's get into it. So with the first one, we factor an a out of these two, and we factor a b out of these two. Then we have a common factor of y minus 3 to factor out the front, and there's our final answer. For the second one, we've got a common factor of x squared here, and we've got a common factor of 3. So we'll factor those out of each half. Once we've done that, we have x plus 1 in common, and we can factor that out the front of the whole thing, leaving us with x squared plus 3, final answer. For C, we've got an x and an x in common here, and in the second half, we've got a y and a y in common. So we'll take the x out of these two, and then we'll take the y out of these two. Straight away, you know you've done it correctly if these two brackets are matching up, and then you can pull those two brackets out the front and have your factored answer right there. For the fourth one, we've got a common factor of 3a for the first piece, and we've got a common factor of 6a for the, 6b for the second piece, leaving us with a plus 3 in both front and back. Factorize the a plus 3 at the front, and then we get their final answer. For a little bonus mark, I guess you could say this answer is not fully factorized. If you can answer in the comments why this answer right here is not fully factorized, I'll give you the $1 million that I owe Emily that I will never pay her. Okay, and for question E, it's a bit of a weird one, but keep in mind that pi is just a number and r is just a letter. So for the first half, we can factor out the pi r for these two. And for the second half, we can factor out a negative 3. So pi r out of the front half gives us this. Negative 3 out of the back half gives us that. Factorize out the r plus 2 that's in common, and we have our final answer. So well done if you got that. That's a bit of a weird question, but it's essentially the same thing as the other ones, just looks a bit scarier. Okay, cool, that's gonna do it for today. There will be an exercise on MathSpace for you guys to get some practice with this stuff. Or if you aren't a fan of MathSpace and you prefer to do some hands-on writing, you can have a go at these questions instead and flick me an email or upload a photo with your answers, and I'll accept that as submitted work instead of MathSpace if that's your preference. But completely up to you. I'll see you guys in the next factorizing lesson. Thanks so much if you made it to the end, and I'll catch you next time. See you, legends.